Hello, everyone, and welcome back. So in this section, we're talking about combining the laws of logarithms, and we talked about three different ones in the previous video. We talked about the power law, the product law, and the quotient law. And so over here, what I want to do is I want us to be able to combine all of these together and use them at the same time. So let's have a look at what we have over here. I will also introduce a quick quick law that yes, we didn't cover in the previous video, but it's nice to know. So kind of keep that in mind that I'll introduce it in a little bit in this video. So over here it says determine the value of 3 log 2p minus 3 log 2q if p over q is equal to 8. Now it's immediately giving us over here we see subtraction, same base. So we're thinking, okay, well, I could use division, right? Because division says that if I'm dividing like this P and this Q, then I can always write it like this as subtraction. But that's only if we don't have anything in front. And so this 3 needs to be brought inwards. Remember how we talked about the log law where I have log base a of m to the power of n. I could always bring this n downwards over here. And so I could write it as n log a of m, right? And so because we can write it like this, I can do the same as well. If I can go in this direction, then I can always come back in this direction as well. So if I have it sitting outside, then I can always bring it to the top. Right. And the reason we want to do this is because the only way we can use the rule for quotients where I have log base a of m over n is if there's nothing out here. Okay, so I need to make sure that that is not there. Or we could say, okay, well, we're subtracting two things and this is a common factor, so I could pull it out. There are different ways of doing this. All right, so we can use quotient law. We can factor it out, and I'll show you both ways. So this is factoring. So I'll do that in blue so you can see it. And we'll use quotient law, power law, so you can see that as well. All right, so let's have a look at power law first. So if I bring that 3 up there, then I'll go log base 2 of p to the 3 minus log base 2 of q to the 3. Okay, let me move that a little bit lower or a little bit to the side. That's not interfering. All right, so now that we have that, now we can use the law where, the quotient law, where I say if I have log base a of m over n, then I can write it as log base a of m minus log base a of n. And so we're already starting on this side, and so we want to go in the opposite direction. We want to say, oh, okay, well, that's log base a, which is 2, of the first one over the second one. And so this is P3 all over Q3. Now, keep in mind, we don't know what P is and what Q is, but what we do know is that P over Q is equal to 8. And so what I can do here is I can bring this 3 outside, right? They both share a power of 3, and I can use then power of a quotient. And so a power of a quotient, remember from exponents, if I have 2 over 3, this is the power of 5, this is power of 5. I can rewrite this as 2 over 3 all to the power of 5 because this goes inwards to both anyways. All right, so let's do the same thing over here. This is going to equal to log base 2 of p over q to the power of 3. And we know that p over q is 8, so I can rewrite that. I can go log base 2 of 8 to the power of 3. And then what I can do here, I can go, okay, well, if it's log base 2 to the power of 3, then what I can do here is I can say, okay, well, is this, for instance, a multiplication of some things, or is it, or can I simplify this? So over here, I'd say, okay, well, let's say I rewrite this as log base 2 of 4 multiplied by 4 multiplied by 2. Okay. And so over here I can say, okay, well, or I can even show you a cooler trick. And this is where I said I'm going to introduce something. So I'm going to introduce it right now. So I'm going to write it like this: 2 to the power of, well, what's 8? 8 can be written as 2 to the power of 3, right? And so 2 to the power of 3 is 8. And so I can do power of a power here and rewrite this as log base 2 of 2 to the power of 9, right? 3 times 3, power of a power. This is power of a power. So you're using laws from exponents as well. And over here we use power of a quotient. All right. And so now I'm going to show you this cool trick where if you ever have something like this, log base A of A, well, this is just equal to 1, right? And let me tell you why. So you're saying, remember how we said that when we convert this into exponential, we go base to the power of the other side is equal to A. Well, A to the power of 1 is equal to A to the, so let's keep that as Y, as if we don't know, and then we're going to prove that it's equal to 1, okay? So A to the power of Y is equal to some A to the power of 1. Well, then what is Y? Y is equal to 1, okay? And so anytime you have this situation over here where you have the same base as the argument, so these two are the same, the base and the argument, this is always going to equal to 1, okay? All right, so I could use this over here. I could go, okay, well, I could bring this 9 down here using power law, and then that's going to equal to 9 log 2 base 2, base 2 of 2, and you can see where I was going with this. So now I've created this scenario where it's log base A of A, and so that is all equal to 1, and so I have 9 multiplied by 1, okay? And so our final answer is just going to be 9. And how did we do this? We used a bunch of laws, right? We used over here power of a quotient. So we used some exponent laws, power of a power. We used over here the power law, so a logarithmic law. We also used the quotient law of logarithms as well. And so we use plenty of laws over here. And we also use this law over here where I have log base A of A is equal to 1. So we use plenty of laws here in order to get our final answer of A. And typically when you answer logarithmic questions of using laws, typically you will be combining laws anyways. It won't just be, oh, use this one law. It will typically be a combination of some laws. I did promise you that I'll show you what it would look like using factoring. It doesn't change much. It's just going to look like this. Let me do it on the side over here. It's going to be 3 log 2p minus log 2q. It does make it simpler though if you used factoring. Remember, we said in earlier maths, if you ever have a chance to factor. So over here, this is using factoring. All right, so over here I factored out that 3, and so it makes things a lot simpler because look at this. Now I can use quotient law, and I can go log base 2 of p over q, which is 3 multiplied by log base 2 of 8. And then I could rewrite 8 just like we've done over here. So I can write this as log base 2 of 2 to the power of 3. Bring that 3, remember I can use power law, can bring this 3 down, and I will do that. So it's going to be 3 multiplied by 3 log 2 of 2. Well, log 2 of 2, that's just equal to 1. And so it's 3 times 3, which is equal to 9. Okay? So that's pretty much it for combining loss. Just make sure that when you do questions on using loss, typically you will be combining. So just be smart with how you want to combine, which approach you want to take, and which would be the most efficient and fastest way, okay? All right, everyone. So that's it for this section. I'll see you in the next. Bye.